So I'm a bit sad today because it's my last day on Chikyu, this wonderful ship of the IUDP. But the good news is we still have one lecture together, and this time we're going to look at how we build a stratigraphic timescales and the different controversies that have existed in stratigraphy. So you've covered a lot of ground in the previous 7 lectures, but what's still missing is the ability to basically bring all these different stratigraphic methods together and add some and be able to build a stratigraphic time chart, to be able to understand geological timescales. And that's what we're going to do today. Basically, what we want to be able to do is to understand how this timescale that you're looking at right now, which is defined by the International Commission on Stratigraphy, well, how is it built? Why do we define the Neogene, the Miocene, for instance, or the Messinian the way we do? And how do we come up with ages? And perhaps just as important, why are those ages changing? Why is this thing a constantly evolving timescale? So you have to remember that originally, stratigraphy started very humbly as lithostratigraphy, the correlation of rock based on their properties. And you can see an example between Green River and Westwater in the Colorado mountains, where essentially each formation is tied to the same formation, and these two sections are actually several hundreds of kilometers apart. Lithostratigraphy at the very beginning of the 19th century was all that scientists had to go about. The concept of chronostratigraphy evolved with the beginning of the 19th century, and of course chronostratigraphy and especially biostratigraphy became a very important part of the geological timescales in the 19th century. But even these two approaches were not always enough to completely resolve stratigraphic problem, and that led to some very interesting controversies and heated debate. And I want to talk about two giants of stratigraphy, Sir Robert Murchison here on my left and Sir Adam Sedgwick here on my right. Now these two gentlemen became enemies but started as friends, and this is the story of how this happened. It actually all started pretty well for our two friends. With the notion of a new stage for stratigraphic rocks, because they recognize that the rocks that they saw in the Lumenton Quarry in Devonshire were actually unique. They had a unique fossil assemblage and some unique properties of the rock. So the key word here is really fossil. So Murchison and Sedgwick working together actually won a debate against Delabèche and others, and they came up with this stage that they called the Devonian. So you can see here a theme. The stage name comes from the locality where they were first described, and we'll revisit this later. Sedgwick and Murchison worked in the south of Wales, and there they defined a unique succession of rocks that were extremely deformed. They were tectonically deformed, so hard to work on, very hard to correlate to other rocks, but they look much older than anything they knew. And in Wales, they defined what is now known as the Silurian. So far so good. Our two stratigraphers are working hand in hand to define both the Silurian and the Devonian, important subdivisions of the Paleozoic. But Sedgwick was also working in the north of Wales, in the Cambrian mountains. And there he uncovered a series of rocks that seemed to be older than everything and had no fossils. So he termed these rocks after the Cambrian mountains, the Cambrian. So up to now, we still have the three subdivisions, Silurian, Devonian, and the Cambrian. And you can see it here. This is their publication, Murchison and Sedgwick, 1835, where we have the Devonian at the top, the Silurian here in light blue, and the Cambrian. But problem was brewing, because if you think about it, what these guys had done is they had taken stratotypes or sections in three different locations that are quite far apart from one another. The Devonian here in the south of England, the Silurian in the south of Wales, which was tectonically deformed, and the Cambrian in the north of Wales, which was based purely on lithostratigraphy because there was no particular succession of fossils. We could not find, or Sedgwick did not find any fossils in the Cambrian. And this, of course, was a recipe for controversies, because it was very hard to know exactly where the boundaries between these different subdivisions was, since you could not find physically the contact between them. And it became apparent that the Silurian and the Cambrian somewhat overlapped. The base of the Silurian overlapped with the top of the Cambrian. So that needed to be resolved, and Murchison was the first one to try to resolve it. His solution was very simple. He basically defined the Silurian as comprising the top of the Cambrian. So he extended the Silurian down, and he said the Silurian can be defined as two different zones, the lower Silurian and the upper Silurian, and the Cambrian is just that much shorter. Of course, Sedgwick did not like this solution because his Cambrian, the one he had defined, became a much less important subdivision of the rock record. So he came up with another alternative. And you can guess it. Sedgwick's solution in the 1850s was to say, no, the Cambrian stays the way I've defined it, but I'll just say that there is a lower Cambrian, and the zone that is contested, so the zone where we have overlap between the original definition of the Silurian and the original definition of the Cambrian, I will simply call the upper Cambrian. But Murchison did not like this. And being a gentleman, he responded in the fashion you can expect. He simply ignored everything that Sedgwick had done and said the Cambrian is irrelevant, there's no fossil, the whole thing can be called the Silurian. So he extended the Silurian down to the base of the Cambrian, tried to get rid of the Cambrian, and defined the lower and upper Silurian as lower Silurian corresponding to the original Cambrian and upper Silurian corresponding to the original Silurian. At that point, the two friends were enemies. Their friendship was completely broken, and this was one of the most embarrassing feud in stratigraphy in the United Kingdom, and everybody, all the other stratigraphers, tried to resolve that issue so that the field could move on. And it is actually Charles Lapworth who came up with a compromise and a solution in 1879. He defined a new stage that he called the Ordovician. So now we have the Silurian, the Ordovician, which is also named after a Celtic tribe from Wales, and the Cambrian. And the Ordovician comprised that area of the rock record that was contested between the Silurian and the Cambrian. So you can see that there's a lot of politics going into the definition of that timescale, and a lot of pride as well. But there's something you might not realize at this point. This whole Cambrian controversy had actually a very deeply rooted reason. And that reason is that people understood even way back in the 19th century that below the Cambrian we had what was then named the Azoic, or what we named the Precambrian. And the Precambrian is characterized by the absence of shells. So for 19th century scientists, this meant the absence of life, which we know today to not be the case. So really, whoever could define the base of the Cambrian would define in their mind the appearance of life on Earth, which was a major event. What they did not realize, of course, is that the base of the Cambrian in the UK is characterized by a major unconformity. So really, they did not have a complete record, so the whole controversy was for nothing. But I personally find it interesting to realize that in science, there is a human side as well. And this 19th century example shows us that stratigraphy is no exception.